Hello everyone and welcome back to today's episode. In today's video, we'll be discussing graphic processing unit, otherwise known as GPUs. They are the powerhouse behind the stunning graphics you see on your screens. So whether you're into any sort of gaming or content creation, or you're just looking to upgrade your PC, choosing the right GPU could either make or break your experience. So you may be asking yourself, what then is the right GPU? Don't worry, we've got you covered. In this video, we'll be breaking down everything that has to do with GPUs, from their basic functions to how to choose the right GPU that fits your needs. Without wasting much time, let's get started. First off, let's start by defining a graphic processing unit. What is a GPU? Well, a GPU can be defined as a specialized electrical circuit designed to rapidly manipulate and alter memory to accelerate the creation of images, videos, and graphics to be displayed on a screen. Now let's look at the functions of a GPU in a computer system. First off, GPUs are responsible for rendering videos, images, and animation for displays on computer monitors, TVs, and other screens. Unlike CPUs that are designed to handle tasks sequentially, GPUs are built to handle multiple calculations simultaneously, which makes them suitable for tasks like video editing, 3D rendering, and machine learning. Since graphic-related tasks are usually resource intensive, GPUs usually do the heavy lifting, thereby freeing up the CPU to handle other operations. Now, let's look at the components of a GPU. Just like any other device, GPUs consist of various components that enable them to perform effectively. One of such components is the cores. Depending on the manufacturer, you could see names like CUDA cores or streaming processors. They all refer to the same thing. These cores are the processing units within the GPU that perform the calculation. So the more cores a GPU has, the better its performance. Another component we'll be looking at is the VRAM. The VRAM is the dedicated memory within a GPU that is used to store textures, frames, and graphical data. So the higher the VRAM, the better the GPU's performance at high resolution. Then we have the clock speed. The clock speed is the speed at which the cores present in the GPU process data. So the faster the clock speed, the better the GPU performance. And this clock speed is measured in megahertz or gigahertz. This brings us now to the cooling system. As the GPU works and processes data, it generates a lot of heat. So most GPUs come with a form of cooling system. This could either be fan or a liquid cooling system, which helps to maintain optimal temperature. Now let's look at the types of GPUs. There are two major types of GPUs. One of them is the integrated GPU and the other is the discrete or dedicated GPU. An integrated GPU is a GPU that is integrated into the system's motherboard or exists within the CPU die. They are usually less powerful but energy efficient and cost effective. An example of an integrated GPU is the Intel UHD graphics processor. This can be found in a CPU like the Intel Core i9-14900K CPU. Another example of an integrated GPU is the AMD Radeon Vega GPU, and this can be found in the AMD Ryzen 9 9950X CPU processor. On the other hand, dedicated GPUs are specialized cards which come with their own dedicated VRAM. They are much powerful and are used for gaming, professional workstation, and high-performance tasks. Examples of dedicated GPUs are the NVIDIA GeForce RTX series and the AMD Radeon RX series of graphics cards. Now we have gone through the basics of GPUs. How do we now measure the performance of a GPU? How do we know how powerful or how weak a GPU is? Here are a few metrics to consider. First is the frames per second or FPS. This determines how smooth the gameplay or video playback would be. For most people who are into gaming or video editing, a GPU that can give 60 frames per second gameplay or playback is ideal. But for those who want to become more competitive, they can aim aim for GPUs that give them 120 frames per second. Another key metrics we'll be looking at is the VRAM. The VRAM is crucial for handling high resolution textures and multitasking. For those who handle 1080p material, 6 to 8 gigabytes of VRAM is ideal. But for those who handle 4K material, then anything from 12 gigabytes and above is what they should go for. And lastly, for benchmark, there are certain websites that have done series of tests on virtually every GPU in the market, and the results are published there. So all you need to do is to go there and select the GPUs you want, and you can even compare and contrast. So if you need more information on GPUs, you can visit websites like User Benchmark and 3D Mark. Now let's talk about the key players in the GPU market. In fact, there are two key players, NVIDIA and AMD. NVIDIA is known for its cutting-edge features like ray tracing and DLSS. DLSS is an acronym that means Deep Learning Super Sampling. AMD, on the other hand, is known to provide better value for money with competitive performance and features like FSR, otherwise known as Fidelity Effect Super Sampling. Now let's look at the common uses of a GPU. GPUs help render high-quality graphics, textures, and effects in real time for video games. GPUs are used in video editing, 3D rendering, and graphic design in softwares like DaVinci Resolve, Blender, and After Effects. GPUs accelerate training and inference of AI models due to their parallel processing capabilities. GPUs are used to solve complex mathematical problems which are required in mining cryptocurrency like Bitcoin and Ethereum. GPUs are also used for scientific simulations, data analysis, and other computer-intensive tasks. In our previous video, we talked about CPUs, that's Central Processing Unit. Today, we're talking about GPUs, Graphic Processing Units. How do they differ? What makes these CPUs different from GPUs? Now, let's look at their differences. GPUs are optimized for parallel processing, while CPUs are optimized for sequential tasks. GPUs have thousands of smaller cores within them, while CPUs comprise of few powerful cores. GPUs are designed to be faster while handling complex tasks like 3D rendering and video editing, while CPUs are optimized to handle basic computer operations. GPUs are also essential for tasks like artificial intelligence, machine learning, while CPUs are designed to be faster at general operation. So while selecting your GPU, a few factors to consider are the purpose. What are you using your GPU for? Next is budget. How much are you willing to splurge on a GPU? And then the next factor to consider is compatibility. Is it compatible with your motherboard or the current processor which you are using? So alright, let's wrap things up. If you are doing computer intensive tasks such as photo and video editing, gaming, artificial intelligence, and machine learning, 3D rendering, you must invest in a GPU. The key factors to consider when choosing a GPU are the frames per second, your VRAM, and benchmark results. NVIDIA and AMD are the key players in the GPU industry. So here are some GPU recommendations for you. If you're on a budget, then GPUs under $300 will be ideal for you. They can handle 1080p gaming and light creative work. Examples are NVIDIA GTX 1660 and AMD RX 6600. For mid-range GPUs, they cost between $300 and $600 and are ideal for 1440p gaming and more demanding creative tasks. Examples of such GPUs are NVIDIA RTX 3060 and AMD Radeon 6700 XT. For high-end GPUs, they are above the $600 price point and are good for 4K gaming, ray tracing, and professional workload. Examples are NVIDIA RTX 4090 and AMD RX 7900 XTX. And that's it on this episode. I hope we were able to educate you on what a GPU is, types of GPUs, the functions of a GPU, and we were able to give you some recommendations on what to choose if you're in the market for a GPU. Just in case we missed out on anything, kindly share your thoughts in the comment section, and don't forget to like, subscribe, and hit the notification bell so that you can be updated on subsequent tech videos. Thank you for watching, and see you in the next one.